this question. So here we go. There's a lot of information, so I'm going to point you to the right direction. Again, I've just redrawn the picture out again. So I've added a few points on. I've added that object B initially. This is the initial scenario before the collision. The velocity of B is 0. Velocity of A is 5 meters per second. Velocity of A after the collision is 2 meters per second. Velocity B is unknown. The angle from the horizontal of velocity A, object A, is 30 degrees, and the angle relative to the horizontal for object B is theta. So my first statement in the notes were, and I'm going to write this down in a slightly different way, the momentum in the x direction, the total momentum in the x direction initially equals the total momentum in the x direction finally or afterwards. And the total momentum in the y direction initially is equal to the total momentum in the y direction finally. So momentum in each dimension is conserved separately. So what we are going to do is we are going to look at the x direction. I'm going to come back to this picture over and over again. We were told in the question that the mass of A and B are both 0.1 kilograms. So let's have a look. The x direction first, so we're concentrating on that. The momentum in the x direction initially means the momentum of A plus the momentum of B initially is equal to the momentum of A and the momentum of B afterwards or finally. I've used the notation U as initial velocity and V as final velocity. This is for two object collision. If it was multi collisions, I'll have to add more momentums before and after. So here we go. The momentum before the collision of object A is the mass of object A, which was 0.1, times by the velocity of 5 meters per second. Object B is not moving, so the momentum is 0. Remember, this is the x direction. And object A is moving in the x direction. So if I was to define a set of coordinate system, I'm going to call that direction x. I'm going to call that direction y. So this direction's x, this direction's y, as you normally have on your graphs. Okay, so in the x direction, so object A is only moving in the x direction. There's no y component for that. So this is speed in the x direction. Similarly, for object A after the collision, now the object is moving in both x and y directions. If the object has a 2 meters per second speed at an angle relative to the horizontal of 30 degrees, then the component of speed in the x direction is 2 cos 30 degrees. Okay, so 2 cos 30. So the mass of object A is 0.1. The speed is 2 cos 30. Object B has a horizontal component of speed as velocity of B times by cos of this unknown angle. So VB cos theta. So that's the momentum of object B after the collision. Now I'm going to multiply everything out and rearrange, and I get the component of velocity in the x direction, which we call VB cos theta. That's the component in the x direction of object B after the collision. We get 3.3 meters per second. Now that was just rearranging that. Now that is the velocity in the x direction. I'm just going to call it the velocity of B in the x direction after the collision. So that's 3.3. Now let's look at the y direction. We determined that object A is only moving in the x direction. There's no y component. So the y component of velocity is equal to 0. Object B was not moving before the collision, so that has a y component of velocity equals 0 as well, and then overall momentum will equal 0. Now, object A has a mass of 0.1, but if we go back, the component of velocity in the vertical direction or the y direction is 2 sine 30. And for the velocity component in the y direction for VB is VB sine theta. So what we've got is object A has a vertical component of velocity is 2 sine 30 or in the y direction, and VB sine theta in the y direction. That's the component of velocity for object B after the collision. Now, when you may think, oh, okay, I must include a negative sign because it's pointing downwards. The answer will end up being negative. So that will take care of itself. And if we do rearrange this, we end up with VB sine theta, the vertical component of velocity downwards, as equaling minus 1 meters per second. That minus tells us and confirms that velocity component is downwards. Okay, considering y going upwards is positive, then going downwards is negative. Now that is the velocity of B in the y direction. We're just going to call that VBY. So velocity of B in the y direction after the collision is minus 1 meters per second. Now, you're possibly wondering, why am I going down this route? Why am I splitting into x and y? Now, you've seen that the momentum is conserved in the x direction and conserved in the y. Okay, how is that going to help me get the velocity, the magnitude of velocity, the overall velocity acting this way? Now, if we see, we can use trigonometry or Pythagoras to find the velocity of B. Because we found this component and we found this component, now we can use trigonometry and Pythagoras to find both the angle and the magnitude of the velocity. So let's have a look in more detail. So we've just seen that the component of velocity going downwards, the y component, is minus 1 meters per second. How do we get that? We use the conservation of momentum in the y direction. We've got the velocity of B in the x direction after the collision. How did we get that? We use the conservation of momentum in the x direction. Now we can see that we can use Pythagoras to find the magnitude. So the value of the velocity of v is 3.3 squared plus minus 1 all squared, square rooted, and we get a speed of 3.45 meters per second. And we can then use trigonometry. So tan is the opposite over the adjacent, so that's minus 1 there. That'll be the opposite. The adjacent to the angle is 3.3, and we get an angle of minus 17 degrees. So what's the significance of this minus sign for the angle? We can see that there's positive 30 degrees when we go anti-clockwise and clockwise below in the opposite direction will of course be negative. Okay, so here we've got the two angles, and what we've done is we've found the horizontal and the vertical components by using the conservation of momentum in each dimension separately, and using trigonometry and Pythagoras we can find these two angles. Now you may not have used these two, trigonometry and Pythagoras, to get VB and theta. You can continue. You could have gone the other way. There's another way of doing it, and many of you mathematicians can. We know VB sine theta is minus 1. We know VB cos theta is 3.3. And if we divide this by this, the VBs cancel, and the sine theta over cos theta is tan theta. And we're back at this point here, and the angle is minus 17 degrees. And if we just substitute the angle back into any one of these two expressions that we had earlier on, we can find that if we substitute, let's say, into VB sine theta equals minus 1, we find the same magnitude of velocity of 3.45 meters per second. Both ways are valid. Mathematicians, you may want to use this technique. However, know this technique also.